All right, so here we have a definition of a vertical asymptote. We know how to find where vertical asymptotes are. That is in rational functions whenever the denominator is going to equal 0 and it doesn't cancel out. The definition of a vertical asymptote says that if the limit as x approaches c from the right of f of x equals positive or negative infinity, or the limit as x approaches c from the left of f of x equals positive or negative infinity, then x equals c is a vertical asymptote. It can just be one-sided, or it could be from both sides. It just depends on what type of function you're looking at. Like, for example, like a log function has a vertical asymptote that only comes from one side there. So we've already talked about any value that causes the denominator of a simplified function to equal 0 will be the location of a vertical asymptote. So this is just a little bit of review. If I look at number 1, where's the vertical asymptote on number 1? X plus 2 gives us where we find the vertical asymptote, and we end up with negative 2 as our vertical asymptote for that. All right, for number 2, this one looks like it will factor. Will the top factor? It will not. We'll just have to leave it, x squared plus 4. But how could I factor the bottom? X plus 2, x minus 2, right there. So I would get vertical asymptotes where on this one? 2 and x equals negative 2 would be vertical asymptotes for that function. So you're looking at places you have zeros in the denominator. Trig stuff's a little harder. Everybody have memorized their cotangent ones here. I've figured probably not. But you should have memorized what cotangent is. What is it? Cosine over sine. So cosine, it can also be 1 over tangent, but cosine over sine will be a little easier to help us here because we know the unit circle in sine and cosine. So cosine of pi x over sine of pi x. And whenever we look at that, whatever is in the bottom cannot equal 0, right? So we want to think on that unit circle, where does sine equal 0? Okay, right here at 2 pi, because your coordinates are 1, 0, and sine is your y coordinate. Also over here at pi, or if we want to call 2 pi 0, we could, right? So now what we have to be careful of is this already has the pi in it, right? So we're going to have vertical asymptotes where the stuff on the inside, which is pi x, equals pi, or where pi x equals 2 pi. Or would it be correct to say that pi x could equal 0? Well, we're looking for, you're right, I could probably put not equal to for all of these here. But that would give us a vertical asymptote, right, if pi of x equals 0. What about if pi of x is 3 pi? 4 pi, 5 pi, 6 pi, all these end up in the same spot, right? So this like keeps going. And if I solve this, I would divide by pi. And right here, x can't equal 1. And over here, I divide by pi, x cannot equal 2. And right here, x cannot equal 0. And over here, x cannot equal 3. So what, this continues on. numbers would give us zeros in the denominator here. It's definitely 1, 2, 0, 3. What else? Pretty much all integers, right? 4, 5, 6, even negative numbers. It would you just spin backwards around that unit circle. So you could write this a couple ways. You could do dot, 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 -2, -1, 0, 1, 2, dot, 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 just to show it's all your integers. You could also say x equals all integers. Can't remember I think Z is the letter for integers. I know we used to do this in college, like X is an element. I want to say it was Z for integers. You might not want to write that down. I can't remember if that's right or not. But you won't see that on the AP exam or anything. It would probably be written out like X is all integers. You don't want to say all real numbers, because real numbers can be decimals or fractions. And decimals and fractions would not work here. Like if I had 1/2, that'd be pi over 2, and sign does not equal 0 there. So you don't want to say all real numbers. Integers will restrict you just to whole numbers and their negatives for that. Okay? And you don't want to say whole numbers, because what are the whole numbers? They're always positive there, so you don't want to. Actually, it might be 0 and positive. All right, what if we want to find vertical asymptotes here? What have we got to do? Factor top and bottom, so we're going to do x plus 4, x minus 2. The bottom will be x plus 2, x minus 2. In this case, we don't have all vertical asymptotes. We have one hole. Where is the hole at? At positive 2, we would have a hole. Where is our vertical asymptote? Okay, so this is still mostly review. Right here, that trig might have not been so much review. Okay. All right, so infinite limits will occur at vertical asymptotes. So if we're looking at a problem like this one here, if you try direct substitution, so if we try direct substitution, we will get 1 squared minus 3 times 1 over 1 minus 1. Does this give us 0 over 0? It does not, because in the top, we will get -2 over 0. So this, without a doubt, tells us the limit does not exist. Okay, so for sure the limit does not exist, but, and if you're doing a problem and there's a answer choice that says limit does not exist, that's your answer, you're done. But most of these are not going to offer us limit does not exist as an answer choice. There will be a positive infinity and a negative infinity. So what's happening here is we've got this vertical asymptote at x equals 1, right? If we look at this equation, even if you factor the top of this, you got x times x minus 3 over x minus 1. Nothing cancels. So that x equals 1 is a vertical asymptote there. So the answer is going to be positive infinity or negative infinity at a vertical asymptote. Since they have asked us to look at the limit as x approaches 1 from the left, we want to look at what's happening from the left. I am going to let you use your calculator on part of these and not on others, because you might see them in either section of the test. So let's do this one, as painful as it might be, without the calculator. Okay, so let's pretend we can't use the calculator on this. So, if that is the case, I would just make a table, and we're approaching 1 from the left. So I might start at -1. And if I plug in -1, I've got -1 squared minus 3 times -1 over -1 minus 1. That is going to be 1 plus 3 over -2. So 4 over -2 will give me -2. That tells me nothing so far, right? But I gotta have a place to start from. Let's try 0 here. For 0, that's a little easier to plug in. We got 0 squared minus 3 times 0 over 0 minus 1. That's going to give us 0 over -1. So we'll get 0 for that. 2 points is not enough to say, like, yeah, we increase there, so it's not enough to say positive infinity. You need to keep going because it could do something else. We don't want to plug in 1 because 1 is going to give us undefined. So we need something between 0 and 1. I would do maybe 1/2. I also would do fractions here. I would not do decimals, but that's up to you on what you're most comfortable with. So if I do 1/2 squared minus 3 times 1/2 over 1/2 minus 1. What do I get when I do 1/2 squared? 1/4 square the top, square the bottom. And this is going to be 3/2 over -1/2. What have I got to do to subtract those fractions right there? Common denominator, so this needs to be a 6. This needs to be a 4. So 1 minus 6 will give me -5 over 4. I know, like, you're thinking, Ms. Hyatt, how could you possibly even put yourself through all of this without the calculator when you could just type it in? There's going to be a few I'm going to ask you to do this for, and try to do it to get extra practice with that. Now I've got complex fraction, dividing fractions, easy as pie. Flip second, multiply -5 over 4 times -2 over 1. I would reduce before I multiplied, and you will get +5 over 2. There. So we got 5 halves there. I'm feeling like it's positive infinity because I am increasing here. I'm going to do one more. I'm going to do 1/10 right here. 1/10 is a lot of times pretty easy to plug in. So 1/10 squared minus 3 times 1/10 over. Oh, let's do 9/10. Sorry. Yeah. No, thank you. I do that more than I'd like to admit. There. Alright, so this is going to give us 81 over 100 minus, let's see, 27 over 100 over -1/10. Oh, yes. Sorry, that one's not squared. Thank you. Okay, if I want to get, you could go to decimals pretty easily on this if you would rather do decimals, because dividing by 10 is just going to move the decimal place once. Dividing by 100 is going to move the decimal place twice. I still think I'm going to stick with fractions. I got 270 over 100 if I get common denominators there. That's going to give me like negative, 189 over 100 over -1/10, -189 9/100 times negative 10/1. You could reduce here, and you're going to get like 18.9 for that. And we're still increasing here, so I feel like positive infinity. So limit as x approaches 1 from the left of x squared minus 3x over x minus 1 looks like it is positive infinity. I'm not going to make you do that on many of them, but I have seen some where they ask you to do this on the non-calculator section. So I am going to make you do this on a few. It can be. You have to be careful with that. Like if it does weird things, like it. I would usually maybe use at least one fraction there or a decimal. Trying to get there close to it. All right. So some properties of limits. Okay. For infinite limits, if your limit as x approaches c of f of x equals infinity. If you're doing a limit as x approaches c of f of x plus g of x, if this limit right here is infinity, and this one is just a number, whatever L is, infinity wins. Infinity is the answer, right? If I'm doing infinity f of x times g of x, and this limit right here is infinity, I will get infinity. Unless L is a negative number. If L is a negative number, then I get negative infinity. Because remember, we talked about yesterday that if you multiply or divide infinity by a negative, it will flip it from positive to negative infinity and vice versa. There. If I have the limit as x approaches c of g of x over f of x, remember this part right here, f of x is the one we said is infinity. If you end up with, it's not really correct. It is not really correct to say that you plug in and you get something like 5 over infinity. You don't really want to write that down. But you can kind of think of it. If you got 5 over an infinitely big number, that is essentially 0, right? So if you find yourself having a number over infinity, it is 0. You don't really want to write this down. It is not really correct to say that this would equal something because dividing by infinity is not really possible. But you can do that. And then these also apply if f of x equals negative infinity, signs just switch on those properties there. So some of this we've already really done. If I'm doing example 6, I'm doing the limit as x approaches 0 of 1 plus 1 over x squared. So the limit as x approaches 0 of 1 plus the limit as x approaches 0 of 1 over x squared. This first part is simple. It is just 1 because it's just a constant. But the limit as x approaches 0 of 1 over x squared. Remember, we're not doing no anymore because x does not approach infinity. If I plug in 0, what do I get? 1 over 0. That tells me that limit does not exist. I have a vertical asymptote at 0. So this is going to be positive or negative infinity. This one is one that's a little easier to check. You know, if you're just plugging in, if you're approaching 0, so like let's say that we approach 2, that'd be 1 over 2 squared, which is 1/4. If I do 1, that'd be 1 over 1 squared, which is just 1. If I do something like 1/2, okay, let's do some scratch work on that. 1 over 1/2 squared would be 1 over 1/4. Dividing fractions is easy as pie. Flip the second and multiply, I'd get 4 right here. What appears to be happening? Looks like it's probably positive infinity. Would it matter if I went and made that a -2? Because this is both sides. It's not going to, because you're squaring that x, so you're still going to get a positive in the end, right? So even if those were negatives, you'd still get the same values. So this is approaching infinity, so 1 plus infinity would give us infinity for our answer there. Okay, for example 7, we're doing the limit as x approaches -2 from the left. So if we think about doing like the limit of the top and the bottom separately, in the top I do the limit as x approaches -2 from the left of x squared plus 1. That would just be -2 squared plus 1, which is 4 plus 1, which is 5. In the bottom, I've got the limit as x approaches -2 from the left of 1 over x plus 2. If I try to plug in -1, what do I get? I'm sorry. If I try to plug in -2, what do I get? I get 0 in the bottom. There's vertical asymptote here. My answer should be positive or negative infinity. Actually, does it even matter if it's positive or negative infinity, since it's in the bottom here? If I have a 5 that's being divided by either an infinitely large number or an infinitely negative large number, it's still going to be 0 either way, right? Do I even need to bother with the chart here? Not really. I could just say that's going to be 0 there. Again, this is not this step right here is not the greatest to write down. Like a true mathematician is going to take issue with that because you can't really divide by infinity. But these don't usually show up without a calculator on problems that you have to explain yourself on. So if it helps your thinking, it's fine.
If it is something over 0, it's always going to be 30.
If you get, yeah. So if you do direct substitution and you get a number over 0, it is going to be, your limit does not exist, which means it's going to be positive or negative infinity. Your exception to that could be some like weird piecewise stuff where maybe it's not asymptote, it's a, you might have like a jump in the graph or something. You can have a limit not exist without it being infinity, but in these types of problems, it's pretty much going to be positive or negative infinity.
Why is 1 over x plus 2 like, or 1 over 0? Why is that positive or negative?
The limit here, when you get, so there's 3 ways, there's 2 ways that your limit can fail by doing direct substitution. So, like in this case, when we do limit as x approaches -2 from the left of 1 over x plus 2, we would get 1 over -2 plus 2, which is 1 over 0. This tells us does not exist. So that part, the bottom part of that limit does not exist. And if you have a vertical, yeah, there's a 0, it does not cancel, and your numerator is not 0 either. So since this does not exist right here, it's either positive or negative infinity for these types of problems. And sometimes you need to worry about whether it's positive or negative infinity. In this particular case, it did not matter because it was in the bottom, and it doesn't matter whether it's 5 divided by 1,000,000 or 5 divided by -1,000,000. Both of those values are just so close to 0, we don't care anymore, right? Now, if this was if this was flipped, then you would need to like make a table and think about whether it was positive or negative infinity, because your answer would be positive or negative infinity, and you would need to know which one. But for this one, it didn't matter. Okay. All right. So, let me look at this. I don't think that I think that we already did 13 through 25 last night, right? Where are we at? No, this is a different page. Let me see. Let me see what these are to make sure I've got it right. Okay. Okay. 13 through 25 is finding. We have not done this. Finding vertical asymptotes. Let's see. I only see one here. We definitely shouldn't do. Okay. Those should be super quick. You're looking at the equation. You're writing down the vertical asymptote. Maybe a couple of them you have to factor, but most of them you're just looking at. I will tell you this on 21. Anybody remember how to factor x to the third minus 5x squared plus x minus 5, that bottom part of 21? I think you do this sometime, but I can't be sure. Have you ever done this? Factor by grouping? Maybe. And out of that first part, you could pull out an x squared, and that would leave you with an x minus 5. And out of the second one, you really can't pull anything out, so you could just put a 1 here, x minus 5. And then, since both of these have x minus 5s, you can factor that out front. So that is how x to the third minus 5x squared plus x minus 5 factors. If you may have never seen any factoring by grouping before, I wouldn't worry about it too much. I don't think it's going to show up on your exam. Just take my word for it that that's how it factors, and then look for vertical asymptotes. I don't see anything else there that is going to be a major issue on that part. Let's see. I feel like that's a little too much without the calculator. Let's stop this part at 43. That just gives you 4 that you have to do without the calculator. So on those, I do want you to, for real, without a calculator, like plug in numbers, make a table, see what's going to happen there. Then for 49 through 59, you can use the calculator to do those limits. So you can put them in y equals and do the table, or look at the graph for those. Okay. Either one. Do try your best to use the TI-89 and not Desmos. I know Desmos is easier and better a lot of times, but there is a slight chance, but only a slight chance, that we'll get to use it on the exam right now. So we need to be using the 89 for those.
Can you go over how to do it on the 89?
To do these on the 89, like if we just put number 49 in here. Oh, everybody probably is because I moved desk around. Oh, and I was supposed to give you guys new seats today, and I didn't do it, did I? Yeah. You want me to tell you your new seats? How about let's do this since we're about at the end of class and you don't have time to start much anyway. I'm going to send you to your new seats, and everybody search for your real book and put it under your new seat. So, Isabella, you'll be over here. Brady, you're with Isabella. Tyler, you're right here. Ethan, you're with Tyler. Which might have been a bad idea because somehow where you have the same last name, I get you two mixed up. Even though you have different first names and you don't look that much alike. But still. Yeah. Lexi will be here. Emma, you're with Lexi. Evan, you're in Lucas's old seat there. Long, you're right there. Beside of Evan, where Emma is at. Xander, you just moved over one desk, and Maggie will be with you. Solana, you move over one desk. Webb, you're with Solana. Let's see. Joshua is in Brady's seat alone. And Lucas, you're in Anaya's seat. Anaya, you move over one seat. some of you didn't move very much. So let's actually move and then find your book and put it under your new desk so that you've got it and get all of your pictures. And while you're doing that, I can pull it up, but we need to put our names in the front of them. I don't know that I told you guys to do that. Let's see. Let's see. I will pull it up. Calculus book numbers. I think it's this. Okay, here's your book numbers.
Yeah, I did already have mine. I need to take a picture.
So 49 is limit as x approaches 8 from the left of e to the x over x minus 8 to the third. So you've got a vertical asymptote at 8, so it's going to be positive or negative infinity. You want to go to y equals, you want to type in your equation. So we'll have e to the, oops, that's wrong, e to the x divided by x minus 8 to the third, like that. And then you can look at the graph or you can look at the table. Either one's really going to be pretty helpful right here. If you look at the graph, that might be the easiest on this one. Because right here would be 8. I don't know. I think it's going to be negative infinity, but it makes me feel uneasy that those numbers are so far away from that line. So if you want to check with the table, you'll hit the green button in F5. And for the exponentials, you can really just kind of look at like what's going on here. 4, 5, 6, 7. That looks pretty much like it's negative infinity. If you want to like type in the numbers like we did before, if you go to the green button and F4, which is table set, or we could have just hit F2. If you go down here and change this independent over to ask, then you could type in like 7.5. Why is it not working? I didn't hit enter to save it, did I? Enter, okay. Table. If I type in 7.5, I'll get a really small negative number, 7.9. So you can see those numbers are getting like more and more negative. So that'll. So you can just do 49 through 59 in your calculator like that. So you won't have much written down for that. Okay. Let's see here.
It's not that it's like far away, it's just that thing is just angle.
Yeah. How about let's see, would it make, can you see it from the back?
Yeah, it's really not the far
It's the
away,
angle.
It's like I cannot
Will it make you happy if I leave Brady alone and put you back there with Joshua?
Brady wanted to
I'll sit next to Brady.
Or I'll switch you. How about let's do that? I'll switch you with Ethan. I'll put you here. So, can you see okay at that angle?
Yeah, I'm good with that.
Okay.
What's happening?
Yeah. So I'll switch you too. The front. Yeah. So I'll put you Isabella here, and I'm gonna put Tyler here. No. See, I need to split them up anyway, don't I? Why do I get them mixed up? It's their last names. Oh my goodness. Yeah. You can go visit him sometimes if you want. I just went with random